Welcome to springlib.
All right, so we have this substrate. It's like a methyl phenyl ketone. And then we're reacting this with a phenylaldehyde in red. Along with base and heat, all in toluene, so sodium hydroxide, toluene, and heat. Okay, so this is the so-called aldol condensation. Right, and we'll note here that between our two carbonyls, only one of them has an enolizable proton. So we know that we're going to form an enolate from this ketone, and that ketone is going to attack the aldehyde. And what I want to do is just draw you the product in a color-coded way that will allow you to maybe see a shortcut to predicting the product from these types of reactions. I'm going to draw everything but the double bond to oxygen on our aldehyde in red, and we'll do the same for our ketone here. Draw this blue. I'm just going to draw phenyl here, and I'm going to note the carbon which has the enolizable proton, and then I will show you how you can jump straight to drawing the product without having to worry about the mechanism, and that's redraw the original ketone, the one that had the enolizable proton. I'm going to draw that as blue. I'm not going to draw the bond to that hydrogen, but I'm just going to mark this as being where that hydrogen was. Okay. Then I'm going to draw a double bond down from that. And what I'm going to do in my head is sort of cut that right there and staple it to the bottom. So I get PH phenyl. Right. And so this is my aldol condensation product. So you're basically looking at your electrophilic carbonyl, chopping off the double bond to oxygen, looking at your nucleophilic carbonyl, identifying the carbon that has the enolizable proton, and then gluing this portion of the molecule to the bottom, keeping the double bond intact. Right. Other than that, you can step through the mechanism, but I think this is maybe the best way of predicting the product without having to muddle through the mechanism each time. As long as you have an aldol condensation, this should get you to the product.